In this video, we're going to start talking about the second main concept of calculus, which is derivatives. And we're going to look at the definition of the derivative. So the derivative is the slope at a point. And we talked about in the first lesson, how we find a slope of the point is we look at the tangent line. So the derivative is also the slope of the tangent line because the slope at the tangent line is the same as the slope at the point. It is also kind of in real life considered the instantaneous rate of change. So it's the rate of change at a specific instant of time. So there's a lot of different notations we use for derivative, and you have to be comfortable with all of them. The first one is the most common. So we put whatever function we're talking about and then an apostrophe and then x. So if my function was g of x instead, I would say like g prime of x. And that would be represent the derivative or the slope of the function. And when we put the x there, we actually find a formula or an expression for the slope. And then we can plug in any x value to find the slope at that specific point. The other one is like dy dx. So if my original equation was like a y equals, then we can write the derivative as dy dx. And so this means d stands for like the change in. So it'd be the change in y over the change in x. The other one, this is the least common, but it does come up, is d dx of f of x. So that means find the derivative of whatever the function is. They usually put in the function there. So it'd be like d dx, and then they would put like x squared. And so that would be find the derivative of x squared or find the slope of x squared, a formula for the slope of x squared. And the process of finding f prime of x or dy dx, any of these, is called differentiation. So we are going to first find it using the definition of the derivative, which is a long way, and then we'll find kind of shortcut rules to make it much easier to find the derivative. But we're going to go back to kind of that concept of secant line versus tangent line and using the secant line to approximate the tangent line to come up with this definition. So we are going to look at this graph, and we are really focusing on the point P, and we want to find the slope at point P. And what we're going to use is we're going to use another point Q, and we're going to use a point Q to find to draw the secant line between those 2 points, and we're going to find the slope of the secant line. And then what we said before is if we move that point Q closer and closer to P, my secant line will be a better approximation for my tangent line. So if I look at P and Q, instead of giving values, we kind of write it in general terms. So P, we're calling x naught is the x value. The little o here, the little 0, we call naught. And then the y value would be f of x naught. Remember, f of something means the y value at that x value. And then what we're going to do is we're going to find q as like h away. So to get q, we would have, here's my x value. The distance on the x-axis between p and q would be h. So this distance here would be h. And so to get the x value for q, we would take the x value for p and we would add h to it. And so we're calling the x value for q x naught plus h. And then the y value for that point would just be f of whatever that x value becomes. So like, for example, if x naught was 2 and h was 1, then x naught plus h would be 2 plus 1, which is 3. And it would just be the x value of 3. But we want to do this in general so it works for any point. So we find the slope between those 2 points. We would use again our y2 minus y1 over x2 minus x1. And so this would be my x2, y2. This would be my x1, y1. And so I would have f of x naught plus h minus f of x naught all over, and then I have my x2, which is x naught plus h minus my x1, which is x naught. Now, the numerator does not simplify because these are inside this function, so we can't do anything about that. But the denominator does simplify, where the x naughts, x naught minus x naught is 0, so they go away, and I would just get h. And so this is an expression for the slope of the secant line. And so the idea is we want h, we want to move our point Q closer and closer to P. So we want to make h smaller and smaller. And so what we do is, to do that, we would say we want h to get closer and closer to 0. And remember, that idea behind approaching or getting really close to is the limit. So for the slope of the tangent line, what we do is we say the limit as h approaches 0, because we want the distance between these two x values to get really, really small so we can move Q closer, of this slope that we found of our secant line. That is going to give me the exact slope of the tangent line. And so this is an expression for the slope of the tangent line. And we often do this kind of without the x naught. We put x, but it's the same idea. So f of x and x, f of x, and here's q, x plus h, f of x, h. And if we move q closer and closer to p, if we make the distance between q and p on the x-axis 0 or close to 0, we are going to get the tangent line. And there's a nice application on Desmos that shows you this. So my green line is the secant line, and my purple line is the tangent. So this would be my point P. This is my Q. And if I move Q closer and closer, so I make the distance between those x values closer and closer to 0, as that approaches 0, that secant line becomes the tangent line. Okay, and it's impossible to make it exactly 0, but we want to get really close, and then it gets really close to it. On either side, so if Q started on this side, if I moved it closer and closer, eventually that secant line is going to be almost the same as the tangent line. And that's kind of the idea behind what we're doing. And so, like I said, we generally do it more with just x and f of x instead of a specific point. And so for this one, my slope of my secant line would be the f of x plus h minus f of x, and then it would be over the x plus h minus x. So again, the x's add to 0, and we just get f of x plus h minus f of x all over h. And then if I want the tangent line, the slope of the tangent line, or that's also the derivative, we take the limit as h approaches 0 of this expression. And that gives me the slope of the tangent line. Okay, and this is called the definition of the derivative. So this is also equal to f prime of x. So the definition of the derivative, if they ask you to find the derivative using the definition, you're going to use this formula. And this gives me the derivative, or the slope of the tangent line. Okay, so it is also called the limit of a difference quotient. The reason is when you divide, it's called a quotient, and then you also in the numerator have a difference. So they also call this difference quotient. So if they say use the difference quotient or use the definition of derivative, you're using this definition. And how you use this definition is you're going to find the limit as h approaches 0. And then you want f of x plus h. Okay, so what f of x plus h means is I'm plugging this value, x plus h, in for every x you see in my function. Okay, so just like as a remember, if I wanted to find f of 1, I would replace every x I see with 1. Just as like an example of something that's more tangible that you've seen. So this would be 2 times 1, which is 2, and 7 minus 2, which is 5. So we replace whatever is here for all the x values. And so because I want x plus h, I replace every x I see with x plus h. When I do that, I have to put parentheses for it. Okay, so this is f of x plus h. F of x is just what they're giving us. So 7 minus 2x. So you can write this all in your function initially. You can write it on the side and then simplify it. It's kind of whatever is easier for you. But what we're finding is f of x plus h is this, 7 minus 2 parentheses x plus h minus my f of x. If I have more than one term, I have to put parentheses around it because I'm subtracting that whole quantity all over h. And then I need to simplify. So what you'll find is if you initially plug in 0, here you would get, this would be like 2 times h then, and this would be just 2x. And so what will happen is you'll get 7 minus 7, which is 0, and negative 2x minus a negative 2x, which is also 0. So if you plug in this initially, you're going to get 0 over 0, which is that indeterminate form, which means you have to factor or simplify and do more work. So we're going to simplify this as much as we can. So what I'm going to do is I'm going to distribute the 2. So I have 7 minus 2x minus 2h. And I'm also going to distribute this negative sign. So then I have minus 7 and then minus a negative, which is plus 2x, all over h. Then I'm going to simplify this again. Same rule as limits. Every time I have to write this limit until I plug it in. So if I look at this, the 7 minus 7 gives me 0. So those cancel. The 2x, negative 2x plus 2x also add to 0. And so all I'm left with is the negative 2h over h. Well, these h's cancel. And so that gives me the limit as h approaches 0 of negative 2. And we said the limit of a constant is just that constant. And so this is what the derivative is of 7 minus 2x. And that should make sense because this is a line and the slope is always in front of the x. So the slope is negative 2. And so the derivative or the slope at any point on this function would be negative 2. Okay, so let's do a little bit harder one algebraically. I want to find, so this would be saying find, another way to put this would be find the derivative using the definition. And if they say that, you are using this formula here. Okay. So let's figure out f of x plus h. And so if I do that, everywhere I see an x, I'm going to replace with the quantity x plus h. So I'd have x plus h squared minus 3x plus h plus 1. And because this one is so long, I'm going to simplify it on the side. So some of you might know what this is squared right away, but just in case, remember squared means you're multiplying it by itself. And because I'm doing that, I need to make sure that I am using FOIL, okay, or first, outer, inner, last. Or some people learned it as I'm distributing the x to both and then the h to both, if you don't know what I mean by FOIL. So we need to make sure we're multiplying that out. This is not x squared plus h squared. You're missing the middle term if you do that. So be very careful with this. So I have x times x for my outer, or my first. So that's x squared. My outer would be x times h, which is xh. My inner would be h times x, which is hx or xh. I'm going to put it in the same order. Plus, and then my last would be h times h, which is h squared. Then I'm also going to distribute this -3. And so I get minus 3x minus 3h plus 1. Then I'm going to combine anything I can. So I have x squared, I have xh plus xh, which is 2xh, because there's a 1 in front if we don't write it, plus h squared minus 3x minus 3h plus 1. Okay, so this is all of what f of x plus h is. F of x is just what they gave me, which is x squared minus 3x plus 1. So when I do my limit as h approaches 0, I'm going to put what I got for f of x plus h simplified. So x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus, and I'm going to put this all in parentheses because I'm subtracting all three of these terms. Okay, so I'm doing minus x squared minus 3x plus 1 all over h. So then I want to simplify anything I can, because again, if you just initially plug in your 0, you will get 0 over 0. You can try it if you want, but you will get 0 over 0. So I'm going to distribute this negative. So I get x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus x squared. Okay, minus the negative is plus 3x, and then I have a minus 1 all over h. And how this should work each time is any term without an h should add to 0. And if it doesn't, then probably something is off when you simplify. So I have x squared minus x squared, those add to 0. I have a 2xh, that doesn't simplify. I have an h squared, no other squared. I have a minus 3x, and I have a plus 3x. I have a minus 3h, no other like terms, but then I have a plus 1 and a minus 1, so they'll add to 0. And so I should end up with all the terms in the numerator having at least one h. And what that allows me to do is now I can factor out an h, because they all have an h in common. So I'm going to pull out an h, and I get a 2x plus h minus 3 all over h, and then the h's cancel. If you don't like that, you can also, the other way to kind of write it, if I was to do it instead, is you're dividing each one of these by h. That's the other way to write it. Like these two steps are equivalent. And so that would give you these h's cancel. So you get 2x plus h squared, remember, is like h times h. So one of these h's cancel and you get plus h. And then these h's cancel. And so you get minus 3, which would be the same thing if I get here and cancel it. So this step and this step are like the same idea, just two different ways to simplify it. And after that step, I would get this. And then because I'm simplifying it and I get h out of the denominator, once I get h out of the denominator, I can plug in 0 for h. And when I do that, I no longer need the limit sign. So notice again, every time I wrote the limit, I know it's a pain, but the limit as h approaches 0 until I plug it in. And then I simplify and I get 2x minus 3. Okay, and so the derivative for this function is 2x minus 3. And this is a formula for the slope of the function so that I could plug in any x value I want to calculate the slope of my original function, which is up here, of this x squared minus 3x plus 1. So I know they're really long. You only have to do one of these on the test, and then in the next module, you'll learn a shortcut so that you can go right from here to this without a lot of work. But for now, you have to do the long way. And if it says do the definition of derivative, you have to do the long way. So that's an introduction to derivatives and using the definition of derivative to find the derivative.